Okay guys, I promise this is the last section in chapter 7. It's 7-8 and it's called geometric sequences. Now you probably don't remember, but when you had Mr. Lankus, he taught you about arithmetic sequences, and that was way back, I want to say it was back in either chapter 4 or chapter 5. But what we're going to do is we're going to talk about sequences today. Now an example of a geometric sequence is something like this: 2, 4, 8, 16, 32, where each time I'm multiplying by the number to get to the next one. Okay? We're going to skip the get ready and possibly do that when we come back in class. But you're going to have to become familiar with some terms, okay? A geometric sequence has a starting value and it has a common ratio. And the common ratio we call this letter R, and we put it in the form A. And then an A would be like the starting value. See how it says starting value A? You should be used to that from yesterday when A meant the initial amount. And the next one would be A times R, pending whatever your common ratio was. And the next one would be A times R, so AR squared. So what we're doing each time is we're just multiplying by the common ratio. So the next one would be AR times R, which would end up just being AR cubed. And this continues on and on until they say to stop. Okay? There is a recursive definition. A recursive definition is kind of an annoying definition. It kind of just tells you a little bit about the sequence. It always states with A to the 1 or A sub 1, and that just means your first spot. You see that 1? That just means your first spot. And then you state whatever the value is, whether it be 2, 3, 5, whatever. And then it says to get to the next ones, you take the one before it and you multiply by R. That's what n minus 1 means. You guys see this here? A sub n minus 1. All that is the fancy way of writing the one before it. You will get used to these sequences and these types of initials and definitions as you continue on in your math career. So that's a recursive definition. We really don't like recursive definitions. They're just kind of wordy. But what we do like are explicit definitions, because those ones actually give us an actual equation that we can use to find something. And it says to find any number in the sequence, you take your first term. Remember, that's what this one stands for. This one's your first term. And you multiply it by your common ratio, what you're looking for, minus 1 as the power. But I think as we move on, that will make more sense, so just bear with me. That might be beneficial for you to come back at the end of the video and see again. Alright, problem 1. First of all, we just need to know if you can identify geometric sequences. So look, we have A, B, and C. Okay? Let's look at part A. Do you think part A is a geometric sequence? Well, let's look at my steps. Divide the second by the first, divide the third by the second, divide the fourth by the third, continue on. So I want to know, if you do 200 divided by 20, you will get a 10, right? If you divide backwards. In other words, some of you are going to ask me, well, Mrs. Angeli, don't you just multiply to get to the other one? Yes, but I just want to make sure that you learn to go backwards, because that will be very helpful for you. Again, you can see that to get from 2,000 to 200, you would divide by 10. You're just going to have to trust me that going backwards is the best way here. When you divide 20,000 by 2,000, you get 10, and this continues on. So what we do is we write yes, this is in fact a geometric sequence. Why is it a geometric sequence? Because it has a common ratio. And that common ratio is what we just did. That common ratio is R equals the value we continued to get, and that was a 10. Okay? Now let's try part B. 4 divided by 2, I have more room here, so I'll actually write it out, is 2. Now try this one. 6 divided by 4 is not 2. This one is not a geometric sequence. Okay? You can stop there. When you don't get one that's the exact same, you can stop. Part C. -5 divided by 5 is -1. Now do this one. 5 divided by -5 is also -1. This pattern continues on. Every time that you divide, you get a -1, right? Therefore, this is, we're going to write yes because it asks us, is it a common or a geometric sequence? Yes, it is. And the R value is -1. Now, before we do the got it's, you kind of need to go back to 8th grade or back to whenever you learned the arithmetic sequence. If anybody is from my classroom or isn't from Southside, I don't know when you learned this, but you should have learned arithmetic sequences before. An arithmetic sequence is when you can add to get to the next number. Okay? So we're going to look at the following, and we need to know which one is arithmetic, which one is geometric, and if there are any, is there any that are neither arithmetic or geometric. So what we're going to do first is we're going to try divide. 6 divided by 3, we're going to try to divide first, everyone, okay? 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. 48 divided by 24 is 2. Each time we try to divide, we get the same answer. That means that this is a geometric sequence. We don't need to test anything else. The R value, or the common ratio, is 2. Okay? Now for part B. 6 divided by, we're going to try dividing by again, since that's the lesson today. 6 divided by 3 is 2. 9 divided by 6 is not 2, so I'm not even going to worry with the other ones. This time I hope you notice that each one you add 3 each time. If you can say that you add something each time or you subtract something each time, you have decided this is an arithmetic sequence. Now whether you remember that or not, whatever. Technically, what Mr. Lankus probably didn't teach you at the beginning was that an arithmetic sequence is a fancy way of saying you've got a y equals mx plus b equation. Let's move on to part C. If you have your old notes, it might be good for you to go look at what an arithmetic sequence is. Alright, part C. Might take a little more work, right? So let's go ahead and figure out what R is. Remember, we need to figure out what we need to multiply by. So in order to figure out what we need to multiply by, we actually need to go backwards and divide. So 1/9 divided by 1/3. Do you remember how to do that? 1/9 divided by 1/3, I hope you remember, is really just 1/9 times 3/1. You guys remember that, right? So you just cancel out the 3 and the 9. You get a 1 and a 3, and then you multiply straight across, and that's 1/3. This one's going to take a little bit longer because we're working with fractions. Now do this. 1/27 divided by 1/9 is really just 1/27 times 9/1. 3 goes into both of these. In fact, I apologize, 9 goes into both of these 1 and 3 times. 1/3 is the answer I get when I divide. The last one I'm going to check is 1/81 divided by the one before it, 1/27. That gives you 1/81 times 27/1, and 27 and 81 cancels to 1 and 3 because 27 goes into 81 3 times. And again, we get this answer of 1/3. So you can see the division gives you the same thing each time. When that happens, this means it's a geometric sequence, and the R value is 1/3. Part D. I think we're clearing this up, at least I hope we are. Part D is going to be a little bit easier. Try your dividing. 7 divided by 4 is exactly that. It's just 7/4. 11 divided by 7 is exactly that. It's just 11 divided by 7. I wrote 4, said 7. 11 divided by 7 is exactly that. Unfortunately, these are not the same, so it cannot be geometric. So what we're going to do is, can you see if you add anything the same time? Do you add 3 each time? Well, from 4 to 7 you do, but from 7 to 11 you add 4. So that's not even an answer. This time, neither is a solution. This is neither geometric or arithmetic. Moving on. So we've learned how to see if something is geometric. Now we need to move on and memorize some ideas. Recursive. We talked about these in the front. And explicit. They describe the same sequence. In other words, the same problem that we're looking at. Remember, I told you, honestly, the recursive one is more annoying than the explicit because it just tells us about the sequence. It really doesn't help us find missing items. The recursive formula first identifies the first term, or the starting term, if you'd rather write the word starting in there. It then defines the sequence using what we call math language. In other words, how do you get to the next number? The explicit formula is more of an equation. Let's put "and" there. It's more of an equation to plug into. It is always the first number times the common ratio, which you got really good at finding in the last page, to the n minus 1 power. This kind of definition up here I didn't have in my old notes. In fact, I'll just show you my old notes. You see it? I didn't have that in my old notes, but I really thought that was something important that you guys needed. So please use that since I put it on here. Memorize that equation. I did that on purpose. Problem 2, we're going to compare the recursive to the explicit. Okay? This side over here is the recursive. This side over here is the explicit. Now, the formula is a general formula. Let's do recursive first, okay? Use the formula. This is the general formula for recursive. A to the first tells you about the first number. Let's move down. So we are given this sequence up here, 7, 21, 63, 189. So what is the first term? A to the 1 is 7. And that's how you start a recursive formula. You say the first term is 7. And then you write a semicolon because we're going to talk about this part here. A sub n, now let me tell you what in words A sub n means. In words, A sub n means the number you want to get to can be found by, that's what your equal sign says. Again, ready? I'm going to point and say it. The number you want to get to can be found by, look at what I'm pointing at now, taking the one before it and multiplying by r. Okay, so what I'm reading to you, I'm reading this in English. I'm going to read it in English one more time. The first term is 7. To get to the number you want, you have to take the number before it, that's what A sub n minus 1 means, and multiply by the common ratio. Now let's move on. A sub 1 equals 7, we already wrote. To get to the number before it, to get to the number you're looking for, you take the one before it and you multiply by, well, what is the common ratio up here by my pinky? Remember, to get it, you go backwards and you divide it. So since when you divide, you get 3 each time, that is the common ratio. You see this entire row right here? That's the recursive formula. Let's say it in English one more time as I point it out. The first term is 7. To get to anything after that, you need to take the 1 before it and multiply by 3. Okay. Recursive formula is very wordy. Again, it just describes the sequence. The explicit formula is definitely more useful. The formula is, ready? I'm going to say it in English. To get to what you're looking for, you have to take the first number in the sequence and multiply by your common ratio to the power of how many you're looking for minus 1. I know that's a lot of work. Now what we're going to do is we're going to plug in what we know. Ready? English. To get an answer that you're looking for, you have to take the first number, in our case it's 7, and you have to multiply it by your common ratio to the power of what number you're looking for, minus 1. Now we can fill out a little more. What does a to the n, a sub n mean? To get the number you're looking for, what does equals mean? You have to take your first number 7, multiply by 3, because that was our common ratio, and then how many ever spots you're looking for, minus 1. So our explicit formula, again in English, to find anything in the sequence, you need to take 7 times 3 to whatever spot you're looking for, minus 1. We are going to make a recursive formula in the got it and an explicit. So title this R, break it apart, title this side E. Okay, let's fill things in. The recursive formula, remember, is a little bit more annoying. You say a to the first is, in this case, a to the first is 2. And then you write a semicolon to start the rest of the recursive formula. To get anything you're looking for, a sub n, you need to take the 1 before it, a sub n minus 1, and multiply by your common ratio. This time, I hope you guys see your common ratio is a 2 when you divide, so we need to multiply by 2. That's the recursive formula. Now let's do the explicit. The explicit formula does this. To get to any number you're looking for, a sub n, you take your first number, in our case it's a 2, and you multiply by your common ratio, again in this case it's a 2, and then you raise that to whatever term number you're looking for, minus 1. Let's try it one more time. The recursive formula, again, definitely more the annoying one. You say my first number, or my sequence starts at 40, semicolon. To get to somewhere else in the sequence, you need to take the 1 before that one, a sub n minus 1, and you need to multiply by, well, we didn't figure that out yet, did we? What's 20 divided by 40? 1/2. What's 10 divided by 20? 1/2. And so on and so forth, right? So you need to multiply by 1/2. Again, that was the recursive formula. Now let's try the explicit. It's a little easier. To get any term you want, you need to take the first number, 40, and then what you need to do is multiply by your common ratio of 1/2, and you need to take 1/2 to whatever spot you're looking for, minus 1. Alright, now I have questions down here. Usually, you know, I teach this in a normal classroom. A lot of people say, why do you even bother with the recursive formula? If it's that annoying, you don't use it. The recursive formula is simply a way of looking at a sequence that helps you define how it starts and what you do. An explicit formula is more or less what you need to do to find whatever number you're looking for. Let me please give you an example. See in part B, 40 was in place 1, 20 was in place 2, 10 was in place 3, and 5 was in place 4. But pretend I didn't know place 4. Pretend all I knew was 40, 20, 10. Now, yeah, you could probably figure out place 4, but what if I asked you about like place 18? Just bear with me. I want to show you how the explicit formula works. If I told you your formula was 40 times 1/2 to the n minus 1, you're looking for the 4th spot, right? So to look for the 4th spot, you would need to do 4 minus 1, or in other words, 40 times 1/2 to the 3rd power. I hope you agree that that's just 40 times 1/8, which is the 5 we were looking for. So by using the explicit formula, you're able to plug in what you're looking for, and that will tell you what the answer will be in that given spot. That last sentence I said to you was so valuable for you to understand. I'm going to say it one more time. The explicit formula lets you take whatever spot you're looking for, plug it in, and get the number that it would be in that particular spot.